Hey parents, welcome to KOEIGO's STEAM and Language School.
We're so excited to have you join us for a little deep dive into what your kids have been up to in our STEAM course at the Kadena Youth Center.
You know, it's really more like a backstage pass to their awesome learning journey.
That's right.
Remember last week when they built those 3D printed catapults and launched turkeys across the room?
Oh, yeah, that was
I
awesome.
bet that was a blast. Well, this week's things are going to get even more exciting as we level up those catapults with, what is it?
A servo motor.
Servo motor, okay.
Yeah, a servo motor is kind of like the motors you see in like your washing machine or a fan.
Okay.
But there's like a special twist.
Okay, I'm intrigued. What's the twist?
Well, unlike those regular motors that just kind of spin and spin and spin,
Yeah.
a servo motor can actually be programmed to stop at specific positions.
Oh, really?
Yeah. Imagine like a robot arm that can like pick up an object with pinpoint accuracy.
Oh, I see.
That's a servo motor in action.
So we're talking about robotics now.
We are.
That's a pretty big leap from launching turkeys, I'd say.
Yeah, definitely a step up.
And our source material actually calls these servo motors actuators, which are basically like the muscles that make robots move.
Exactly. And servo motors are some of the most versatile actuators out there. They power everything from those huge industrial robots in factories to the tiny robots in your kids' toys.
That's crazy. So how did we even get from simple motors to these incredible, precise servo motors?
Well, it all goes back to a guy named Michael Faraday.
Okay.
He made this like groundbreaking discovery about the relationship between electricity and magnetism.
Tell me more.
Well, he found that like if you have a moving magnet,
Okay.
it can actually induce an electric current in a nearby wire.
Whoa.
And the opposite is true too, that like an electric current can make a magnet move.
Really?
Yeah. And this discovery might seem simple,
Yeah.
but it completely revolutionized technology as we know it.
So magnets and electricity, they're the power couple behind all this.
They are.
So how did Faraday's discovery lead to these motors that we see today?
Well, his work showed us that we could use electricity to create controlled motion.
Right.
And, the early motors were pretty basic.
Yeah.
But over time, they evolved and evolved into the amazing machines we have today,
That's so cool.
including the precise servo motors your kids are going to use to bring their catapults to life.
Now, speaking of bringing things to life, our source material mentions Arduino,
Yes.
which the kids will be using to control their servo motors. What is that?
So Arduino is basically the brains of the operation.
But
It's a tiny computer called a microcontroller that can be programmed to control physical things.
oh, okay.
In this case, it's going to tell the servo motor what to do.
Okay.
So it's like the conductor of the orchestra, making sure everything works in harmony.
So Arduino tells the servo what to do, and then the servo makes the catapult move.
Exactly. It's like a chain of command for tiny robots.
I like that. A chain of command.
Yeah. And you know what's really cool? The kids are going to be learning to write the code to program the Arduino.
Wow, so they're learning the language of computers.
They are. It's really exciting. They're going to be able to control the physical world using code.
That's awesome. And I think that really highlights that T in STEAM.
It does, definitely.
Now, our source material also mentions the things called libraries and classes
Yes.
within the Arduino code.
Mm-hmm.
Now, those words sound a little intimidating to someone like me who doesn't code.
Oh, yeah, I get it.
Can you break it down for all the parents out there?
Of course. Imagine you have a cookbook
Okay.
filled with all sorts of delicious recipes.
I like where this is going.
Right. So libraries in Arduino are like those cookbooks. They contain collections of pre-written codes that basically tell the Arduino how to do specific things,
Right.
like controlling a servo motor.
Okay.
And the classes within those libraries are like individual recipes.
Okay.
They give the specific instructions on how to use those codes.
Oh, that makes a lot more sense.
Yeah, it's all about making coding easier and more accessible.
Okay, so it's kind of like a coding cheat sheet for specific actions.
Exactly.
I like that a lot better.
Yeah.
There's also this mention of a map function in the Arduino code.
Yes.
Is this like a treasure map leading to hidden servo secrets?
Not exactly a treasure map, but it's definitely a key part of making this whole project work.
Okay.
So the map function is all about translating values.
Okay.
It's like if you had a test with 20 questions and you wanted to convert the score to a percentage.
Okay. Yeah.
In this case, it's going to help translate the position of a potentiometer.
Now, what's a potentiometer?
It's basically just a fancy knob.
Oh, okay.
And it's going to translate that position into specific angles for the servo motor.
So it's taking human input, turning the knob, and translating that into something the servo motor can understand.
You got it.
And to make things even more exciting,
Yeah.
the kids are going to use a push button to actually activate the servo
Oh, I love this part.
and launch those turkeys.
It's like having a launch control center for miniature projectiles.
I love it.
They're going to be combining mechanical engineering with the catapults, electrical engineering with the Arduino and the servo motor, and then coding to create this functional and interactive system.
Wow, that's really cool.
And that is STEAM in action.
That's a great overview. It's so cool to see all these, seemingly simple components come together to create something so dynamic.
Yeah.
And I love that this project really encourages problem solving and creative thinking.
Absolutely. That's what it's all about. It's pretty amazing to think about what these little servo motors can do.
Yeah, you mentioned robots earlier. Are we talking about those massive ones they use to weld car parts in factories?
Those are definitely some of the heavy hitters in the robot world.
Yeah.
But robots are so much more than just manufacturing. They're used in healthcare, agriculture, exploration,
Wow.
even entertainment.
Really?
Yeah. And servo motors are usually the ones making the move.
So robots are basically taking over the world.
Kind of feels like it sometimes, right?
Yeah, it's like science fiction becoming reality.
Exactly.
So what makes these servo motors so important for robotics?
Well, it all comes down to their precision.
Okay.
And that precision comes from a feedback mechanism built into each motor.
Okay, what does that mean?
Well, there's a sensor inside that constantly monitors the angle of the motor shaft.
Okay.
And that information is fed back to a control circuit, which compares it to the position set by the Arduino.
So it's like a continuous self-check, making sure it's always in the right spot.
Exactly. And if the motor is even a tiny bit off,
Yeah.
the control circuit adjusts the current flowing through it to correct the position.
That's pretty cool.
Yeah, this constant feedback allows for incredibly precise control, which is why they're so essential for robots.
That makes sense.
Yeah.
Can you give us some examples of where this precision is super important?
Oh, tons.
Okay.
Like, one that always blows my mind is surgical robots.
What? Robots doing surgery?
Yeah.
Is that safe?
It's actually incredibly precise.
Okay.
These robots help surgeons do minimally invasive procedures.
Well,
Smaller incisions, faster recovery times, increased accuracy.
that's amazing.
Yeah, the surgeon sits at a console and controls the movements of these robotic arms.
Okay.
And those arms have tiny instruments and a high-definition camera.
Oh, wow.
And the servo motors in those arms provide those incredibly precise movements, mimicking the surgeon's hand motions.
So it's like having a super steady robotic assistant.
Exactly, and one that's way more precise than a human hand could ever be.
I never knew that.
Yeah, it's really fascinating how technology is changing healthcare.
Totally. So what other fields are using these
Oh,
robots?
tons. Like agriculture.
Right.
Robots are being used to plant seeds, harvest crops,
Right.
even milk cows.
Robot farmers.
Robot farmers.
That's incredible.
Yeah, and servo motors are essential for helping them navigate fields, use tools, all that.
What about exploration? Are robots like going into the ocean or out into space?
They are. Like in the ocean, there are these things called ROVs,
Okay.
remotely operated vehicles,
Okay.
and they explore the ocean floor,
Cool.
collect samples, inspect underwater structures,
Wow.
and a lot of them have robotic arms controlled by, you guessed it, servo motors.
So it's like having a robotic extension of yourself down in the deep sea.
Pretty much.
That's so cool.
Hmm.
What about space? Are there robots out there exploring other planets?
Absolutely. The Mars rovers are a great example.
Oh, yeah.
Their robotic arms have cameras, drills, all sorts of cool stuff.
Right.
And they're all controlled by servo motors, allowing them to collect samples, analyze rocks.
I love those pictures they send back.
Yeah, it's amazing, right?
It's crazy to think that there are robots out there exploring other worlds because of those same principles your kids are learning.
Right. Electromagnetism, precise motor control, all that stuff.
Yeah.
It all starts with these simple concepts.
So those turkeys flying across the classroom. That's actually the foundation for some pretty advanced technology.
It really is.
So the kids are going to be testing their servo systems in the next lesson, right?
They are.
What kind of challenges are they going to face?
Well, we're going to challenge them to think about what affects the launch distance and accuracy of their catapults.
Oh, okay.
They'll experiment with different servo angles, launch speeds, even the weight of the projectiles.
So it's not just launching turkeys anymore.
Nope. They're going to dive into some real physics.
Wow, that's really impressive.
Yeah, we want them to understand the connection between the code they write, the design of their catapults, and the physics that make it all work.
That's so cool. That's what STEAM is all about.
It is, integrating all those subjects so kids can see how they connect in the real world.
Exactly.
And speaking of real-world physics, let's talk about projectile motion.
Okay.
Our source material says that a ball thrown at an angle doesn't just travel in a straight line.
Right. Yeah, it curves.
Yeah, it follows a curved path, and that's because of gravity.
Right. Gravity wants to bring everything down.
Exactly.
But why does it curve instead of just dropping straight down?
Well, that's because of the ball's initial horizontal velocity.
Okay.
When you throw a ball at an angle, you're giving it both an upward and forward motion.
Right.
And gravity only affects the upward motion,
Okay.
slowing it down until it eventually reverses and the ball starts to fall.
Mm-hmm.
But that forward motion continues throughout the flight,
Right.
and that's what creates the curved path.
Okay, so it's like two forces working against each other.
Exactly. And the shape of that curved path, called a parabola.
Oh, yeah. I remember that from math class.
Yeah, that shape is determined by the balance between those two forces.
Cool.
The greater the initial upward velocity, the higher the ball will go and the longer it'll stay in the air.
Okay.
But the initial horizontal velocity determines how far it travels horizontally.
So if you want to throw a ball really far, you should aim it high to give it a lot of upward velocity, right?
Not necessarily. This is where it gets a little tricky.
All right.
Our source material says that the maximum range is actually achieved when you throw the ball at a 45-degree angle.
Wait, really?
Yeah.
Why is that?
It's all about finding the sweet spot between the vertical and horizontal components of velocity.
Okay.
If you throw it too high, it spends a lot of time in the air, but doesn't travel very far horizontally.
Okay.
And if you throw it too low, it doesn't have much time in the air, even though it's moving quickly horizontally.
So 45 degrees is the perfect balance between height and distance.
Exactly.
Wow. I never knew there was so much science behind throwing a ball.
Yeah, it's pretty cool, right?
Yeah, I think I have a lot to learn from my kids.
Me too. And that's the beauty of STEAM education. It's a journey of lifelong learning for everyone.
I love that. So what can parents do to encourage their kids' interest in STEAM at home?
Well, there are so many things you can do. Encourage them to ask questions, to tinker and experiment, to follow their passions. Give them opportunities to build things, take things apart, and figure out how they work.
Yeah,
And most importantly, be curious yourselves.
I like that.
Model that love of learning for your kids, and they'll naturally follow suit.
Those are great tips. It's all about keeping that sense of wonder alive.
Exactly. That sense of wonder is what drives innovation and discovery.
Maybe our kids will be the next Michael Faraday, changing the world with their discoveries.
That would be amazing.
So as we're wrapping up this part of our deep dive into servo systems, robots, and projectile motion,
Yeah.
what's the main takeaway? What do we want our listeners to remember?
I think the most important thing to remember is that STEAM education isn't about memorizing facts and formulas.
Right?
It's about developing a mindset of curiosity, creativity, problem solving, and collaboration.
I like that.
It's about giving our kids the tools they need to become lifelong learners who can embrace challenges and make a positive impact on the world.
That's a really powerful message.
It-
Parents, I hope you've enjoyed this glimpse into your kids' STEAM journey.
Yes.
Remember, learning is a team effort, so keep those conversations going, ask questions, and explore together.
And here's a final thought.
Okay.
We've talked about servo motors controlling robots and catapults.
Yeah.
But what about servo motors controlling something much bigger, like entire buildings?
Whoa, that's a big jump?
Yeah. Imagine skyscrapers that adapt to changing weather conditions, bridges that self-adjust to distribute weight,
Wow.
or even entire cities that intelligently respond to the needs of their residents.
That's mind-blowing.
Yeah. And the seeds of that future are being planted right now in your child's STEAM classroom.
That's an incredible thought.
It is.
The possibilities really are endless. Yeah, it's amazing to think those little motors could have such a big impact. From launching turkeys to maybe even shaping entire cities. That's a pretty wild thought.
That is, and that's exactly the kind of thinking we want to encourage in our students. We want them to understand that even the smallest ideas can have a huge impact on the world.
Exactly. We need to help them dream big and believe in their creativity.
Absolutely. And speaking of tools for creativity,
Yeah.
let's talk a little bit more about Arduino.
Oh?
It's such a cool platform for learning about coding and electronics.
Yeah, I have to admit I'm still a little fuzzy on how it all works.
Uh-huh.
Can you give us non-techie parents like a little Arduino 101?
Sure. So at its heart, Arduino is a microcontroller. Basically, it's like a tiny computer on a single chip,
Okay.
and it has all the things a regular computer has: a processor, memory, and input-output pins.
Hmm.
And those pins let it interact with the physical world.
Oh, I see.
So you can program it to read data from sensors, control motors, turn on LEDs, all sorts of things.
So it's like a little brain that can sense its surroundings and then react based on what it senses.
Exactly. And one of the coolest things about Arduino is that it's pretty easy to use, even for beginners.
Oh, that's good to know.
The programming language is based on C++ say, but it's been simplified to be more accessible.
Neat.
Plus, there's a huge online community of Arduino enthusiasts who are always happy to help.
So it's like a very supportive and collaborative learning environment.
It is. That's great. So besides those turkey launching catapults, what else can kids do with Arduino?
Yeah, what other cool things can they create?
The possibilities are endless. They can build robots that follow lines, robots that avoid obstacles, robots that can even solve mazes.
Wow, robots that solve mazes. That's impressive.
They can create interactive art installations that respond to light or sound.
Really?
Yeah, or even design wearable tech gadgets like fitness trackers.
That's so cool. It really does open up a world of possibilities.
It does.
So where do those libraries and classes we talked about earlier fit into all of this?
Well, remember that cookbook analogy we used?
Uh-huh.
Libraries are like those collections of recipes that give instructions for specific tasks.
Okay.
So, for example, there's a servo library that provides the code for controlling servo motors. And within that library, there are classes that define the specifics of different types of servo motors.
So if you want to use a certain type of servo motor, you just find the right class in the library.
Exactly. It's like choosing the perfect recipe for your project.
I like that.
Yeah. And Arduino actually comes preloaded with a bunch of standard libraries for common tasks.
Oh, that's handy.
Yeah. And there are tons more available online created by the Arduino community.
Wow, so there's a whole network of people sharing their knowledge.
There is. And you can even create your own libraries and share them with others.
That's amazing.
Yeah, it's a really collaborative community.
So what about that map function? How did the kids use that with their servo motors?
Well, remember that the map function is all about translating values from one range to another.
Right, like converting those test scores to percentages.
Exactly. So in this case, the Arduino is reading the position of a potentiometer,
Okay.
which outputs a value between 0 and 1023. But the servo motor only understands angles between 0 and 180 degrees.
So they need to translate that information.
Right. The map function takes the potentiometer reading, scales it down, and outputs the corresponding angle for the servo motor.
Wow, that's pretty clever.
Yeah, it's like a universal translator for electronics.
I like it.
So it makes all these different components work together.
Now, we've talked a lot about the technology side of STEAM, but what about the art?
Oh, that's a great point. Art is a huge part of STEAM.
Yeah.
It's what often brings those technical skills to life.
Yeah.
It's about design, aesthetics, and expressing yourself creatively through technology.
So it's not just about building machines, but also about making them beautiful and engaging.
Exactly. In this project, the kids aren't just learning about servos and coding.
Wow.
They're also using their artistic talents to personalize their catapults.
How cool.
Choosing colors, shapes, themes, that's where the A in STEAM really shines.
I love that. So they get to express their individuality through technology.
Exactly.
So as we wrap up this deep dive into the world of STEAM, what's the one thing we want our listeners to take away?
I think the most important message is that STEAM education isn't about memorizing facts or formulas.
Right.
It's about nurturing a mindset. A mindset of curiosity, creativity, problem solving, and collaboration.
I like that.
It's about giving kids the tools to become lifelong learners who can face any challenge and make a positive impact on the world.
That's a great message. And parents, we hope you've enjoyed learning a little bit about what your kids are doing in STEAM.
Yes, it's been a pleasure talking with you all.
Remember, learning is a journey, and it's best done together. So keep those conversations going at home.
Absolutely. And remember, even the tiniest idea can grow into something amazing. So keep nurturing those sparks of curiosity and innovation in your children.
Because they are the future.
They are.
Thanks for joining us on this deep dive into STEAM. We can't wait to see what amazing things your kids will achieve next.